Hello everyone, I'm NANDtoTetris, registration number 18BCE1211, and I'm about to show you this NANDtoTetris recording and how to work with it. So here we go. We open the hardware simulator from the NANDtoTetris software which I've already downloaded, and then we try to load the chip into the software which we have downloaded, and hence the chip that we are loading right now is NAND.hdl, and we are going to test it with a script called and.tst. So now we click on this one, and we test it. So now we run the code, we run the script, and we compare the outputs with the expected outputs. We get shown both of them in the views output over here. So this is the output that we get, and this is what we're supposed to get. Now you can see that both are same. So the software that we have, the hardware that we have simulated is working perfectly. So this was 16-bit and. Now the next thing that we're recording is this was only and, I'm sorry. So this is the 16-bit and this is the script that we have loaded onto the chip, and now we compare. And yes, so here we load the XOR chip now. So now we load the script and we run it, and here we see that it has executed properly. And now we check the output. This is what we get, A, B, and the out. Now we compare, and this is what we're supposed to get, and you can see that it's both same. So our hardware works, our simulated hardware works. Now we test Mach 16. Here is the code, here is when we're running it, and here is the output that we're getting, and here is the compared output, what we're supposed to get. And you can see that they're same, so our code works. Now moving on to other codes, here we go back, and I will now show you other NANDtoTetris codes that I have made. So here is the 16-bit adder that we have coded, and we will see if it was right by running it. So here we go. This is the one that we need to run. We load the chip. Now we run the script and run. So now we check it has executed. Here is the output that we are getting, and we compare it with what we were supposed to get. As you can see, they were same. We move on. Full half adder now is what I will show you. Again, we load the script. The procedure is similar to check if our simulated hardware is working correctly or not. We load the script, we load the chip first, then we load the script, then we run, execute it, and we check our output, and then we compare the one which we were supposed to get. As you can see that they are same, so we have done the coding correctly. Okay. Now the last one, full adder. There we run it. Sorry, script output. This is the output that we get. Compare, and same. So yeah, we're right. Oh, I forgot the main one. Arithmetic logic unit is what the computer uses, what the computer has built inside it. So I will show you this one as well. This one is a big code. So here you go. It executed. I check the output. I think it's right. It is right. So as you can see, we have done it perfectly correctly. Now go on to the third bit. This is the memory module that we're gonna try and simulate now. And Here we go. So as you can see, we are executing this, and now the codes are getting trickier and larger and larger. So this is what we are doing. All right. This is the output that we're getting. Now we need to compare it. Yeah, it's right. It's similar. It's correct. Okay. Now to show you registers. Sorry for the disturbances around. Here we go. This was quite a big code, but we've finished executing it. Now we check the output. Let's compare it, and as you can see, it's same. So what we've done is right. Now finally, just to show the random access memory or the RAM coding, here we go. Okay, it works, as you can see. There are some more RAMs that we can load and run. The code is quite long. Okay, yeah, we're done now. So these were the simulations that I showed you. For some more of them, now we are going to use, here we are using the hardware simulator part of the NANDtoTetris software. Now I suppose we are going to have to use the assembler part, because that's the coding I'm going to show you. Right. So yeah, I'm sorry. Now I'll be opening assembler. There you go. Yes, so now I'll be showing you, I'll be running these assembly language codes, and this assembler is going to convert it to machine language, as will be demonstrated here. So here you go. This is the binary, and yeah, that's it. 16-bit. the end.